Oops. So, let's finish going over this second sheet, please. Where do we leave off? Doctor, you go. Hi. Where do we leave off on the second derivative sheet? Did we get through it all? Yes, we good, or no, there's more? Okay, get it out, please.
Yeah, we got through it all. We got through it all.
Okay, so I want to finish going over this, make sure it's down right. Your notes, you find further mistakes, so feel free to make corrections.
Can I ask about number 1 on the differential?
Yes, we'll get to 50 questions on those. So set 49 fun sheet is what color? Are we good? Is this? So set, this is not obviously not fun sheet. The second derivative. Okay. So one that we haven't finished going over yet.
Yeah.
It's titled set 49.
Yeah.
Fun sheet. We need to finish going over and learning from your mistakes. Yes. Do I have it?
I put quite absent yesterday.
Yeah.
Do I have it?
Yeah.
Okay, where do we leave off? Just a second.
I think we left off on number 10, the second one.
10, the second one?
Yeah.
Okay. Yeah, Mr. Florba, I do not have it. I do not have it. You sure you have it? Okay. So the second one. Okay. So second one, we're finding concave up and inflection points. Yes. Okay. What's the first thing you did? Let's start with domain. Some people are forgetting to do domain. So what's the domain of this problem? All reals that are positive. Yeah, we can't take the log of negatives for 0, yay? Okay. Now we want to find where the graph is concave up and points of inflection. What do we need? First derivative, okay? Feel free to write on your notes making corrections. I would do it in red or ink so it's clear what you did wrong. So your first derivative is 4x plus 1 over x, okay? Okay. Do I need to find where the zeros are the first derivative are? All right. So let's go to the second derivative. Second derivative is 4 minus 1 over x squared. Now what do I want to do? Find the zeros. I can't find where it's turning positive or negative until I find where it's 0. So 0 or undefined. Still kind of ugly, so let's go something like 4x squared minus 1 over x squared. Yeah? All right. So what are the top zeros? X equal? Plus or minus 1/2. Do we agree? What about the bottom zeros? Yes, no. I don't know. Okay. What'd you say? 0? Yeah. Okay. So in terms of sign test, do I need to show the negative 1/2, or because of the domain, can I just start at 0? Okay, cool. Add a fourth. What is the sign of the second derivative? Mr. Ledwidson, what's the sign of the second derivative from 0 to 1/2? Try a fourth. I'll give you a second to think that through. Negative, I agree. And what about after 1/2? Harrison? Positive. Okay, so answering the question, where the graph is concave up and where the graph has a point of inflection. So we would say the graph is concave up. Why is concave up on? 1/2 to infinity because because F double, Y double is positive, okay? What about inflection point? Y has an inflection point at? X equal what, Campbell?
1/2,
Because?
or y prime equals 0.
That's not a requirement. Go ahead, though.
Oh, right, y double prime equals the sign.
Right, okay. Yes. Okay, cool. Yes.
You have to find those limits since like inflection point.
I normally, yes, but in the directions I threw you a bone, I said only the X.
Oh.
So yes, good call. Yes, normally in an inflection point you have to find the X and the Y. But I wanted to take it easy on you because I'm a sweetheart of a guy, so I threw that bone. All right, so let's go with the first derivative here. On the next one, what is the first derivative? Andrew.
1 minus 2 cosine.
Minus 2 cosine theta, yeah? What's Y double? Anybody?
2 sine.
2 sine theta. Alrighty. Where's the 0? I'm going to close this off on 0 to 2 pi not inclusive. So where are the zeros on 0 to 2 pi not inclusive? 0 pi and 2 pi, and we'll just scratch those. All right, so in the interval from 0 to 2 pi, what is the sign of the second derivative from 0 to pi? Maybe pi over 2. What's the second derivative of pi over 2? Positive or negative? Positive. And after pi? Negative. All right, so we conclude y is concave up on 0 to pi, because y double is positive, and y has an inflection point at x equals theta equals, ooh, good call, theta equals pi, because the second derivative should be the same. All right? All right, last but not least, now that you have two tests, people get the test confused and they'll lose sight of which is which, and they'll get little mixtures of both. So this is meant to review the first and the second derivative tests. My goal is to use the second derivative test if possible, and as a backup I'll use the first derivative if the second derivative fails. So let's go here. Y prime is what, Radhika? All right. And do I need to find the zeros here or not in this case? You do. On an extreme problem, you do need to find the zeros. If I take out an 3, hopefully this is factored. What are the zeros that you arrived at? 5 and 3. Okay. So I found where the graph goes flat for a second. Good place where an extrema might happen. Now what do I do? Find F double or Y double in this case. So Y double is 6x minus 24. Now do I set that equal to 0 and sign test?
No, then you plug in those.
All right, I plug in the flat spots into the second derivative. Y double at 3 is negative 6. So combining these two pieces of info, the derivative is 0 and the second derivative is negative, what does that tell me about the shape of the graph? Concave down and flat, so we just found a max. Y or F? Y. There's no F here. Y has a max at x equal 3 because no F. Y prime is 0 and Y double is negative or less than 0. Either one's fine. All right. What about at 5? If I sign test at 5, I get 6. And so Y has a, if it's concave up with flat, then Y has a min at x equal 5 because why do we even have to say Y prime is 0? Isn't it enough to just say Y prime is, Y double is positive? I mean,
No, that is garbage calculation.
why not? Why do I need Y prime 0? Okay, I mean, is this point A? Is Y double positive there? Yeah, is that a min? Yeah, not so much. Okay, so concave alone doesn't mean anything. It's the combination of flat with concave. They both need to be there. It's not just, let's just really kill it. They're both essential, all right? The next one, let's start with domain. What's the domain? All right, 0 to infinity are positive numbers only. Okay, so what is f prime? Mr. Burgess, what's the derivative?
3x squared ln of x
Plus, I'm sorry?
x
X squared. I see where you're coming from. X cubed times 1 over x is x squared. Do I need to find the zeros here, or no, just move on to the second derivative? Need to find the zeros in the critical numbers. Okay, so how would you go about solving this equation? It's not easy algebra, for sure. Well, that is x squared. Okay, so x squared, 3 log of x plus 1. All right. So x squared equals 0, or 3 log of x plus 1 equals 0, yeah? So x equals 0, or x equals? E to the negative 1/3. Are they both in the domain? No. Okay, not in the domain. All right, so now, are we done? Do we circle it? What do we do next? Second derivative. Second derivative, do you want to find it here, or step 3? Let's go step 3. It's product rule. First stays the same, x squared. What's the derivative on 3 log of x plus 1? 3 over x, boom. Plus, second stays the same, 3 log of x plus 1. What's the derivative on x squared? 2x, so maybe 3x plus 3 log of x plus 1 times 2x, yay? Now what do we do? Are you with me? Sorry, am I going too fast for Nicole? Evaluate. Nicole? E to the negative 1/3. That's 3 e to the negative 1/3 times 3 log of e to the negative 1/3 plus 1 times 2 e to the negative 1/3. What a mess. We're almost there. 3 to the negative 1/3. I guess I'll just leave it. What about this, though? What's 3 log of e to the negative 1/3? The natural log and e cancel out, so that's negative 1/3 times 3 is negative 1. That's delightful because, oops, isn't this a sum? How embarrassing. Okay, so this zeroes out, yeah? So what do we conclude? 3e to the negative 1/3, is that positive or negative? It's positive. 3 over cube root of e is still positive. So what do we conclude, min or max? If it's concave up with flat, it's a min. So f or y? F has a min at x equals e to the negative 1/3 because f prime is 0 and f double is positive. Almost done. Okay, let's go to this bad boy. What's the domain? Can I put in negatives into that or not? Yeah, this is the cube root of x squared, right? Can I cube root a negative?
Yes.
You can. All right, so the domain is all reals. We're all good. So let's go with the derivative. G prime is? All right. Where is this 0 or undefined? 0 is a critical number. All right. G double is? Okay. So what about G double at 0? What do you get? Undefined. So the second derivative test fails and we just broke math?
No, it's
Yeah. The second derivative test sometimes fails. If you can't get a sign of the second derivative at your critical number, then you have to go back and use the first derivative test. So the first derivative test, so G double test fails. Now we're going to employ the first derivative test. How do I do the first derivative test again? Sign test around the critical number of G prime or G double? G prime. And before, at a negative, what is G prime sign? Negative, and after? So the function g went decreasing to increasing. What did I see there at 0? The min. G has a min at x equals 0 because negative goes negative to positive. All right. Fine. All right. So this is what I'd like you to do. Leave that on your desk. Clear your desk except for that. Take everything off your desk except for that sheet. You will keep your paper directly in front of you. Your paper is not for anybody else to use.
Don't forget your name, Watts. There's no one on this one.
Would you put your name on that first, please? Find a blank side, put your name on it. Okay? Then give me this problem. Right there. Yes, it is very much a measure of did you pay attention, were you engaged, did you write anything down?
I thought you said for everything.
I said except for that sheet.
Oh, dang, okay.
That's tight.
So if you are not at all engaged, if you're on the phone during this class, here's what we're
Oh my gosh, that is bad.
Show your names on that paper, please. I'll come around and get it. right, after that, we'll hit the second part of the notes on U sub. Okay, take one more minute. All right, here we go. Thank you. Take half of the notes, the use of notes. Would you go to these here in front of you and let's finish use of. Tonight's homework is a whole lot of use of. So if you're good at use of, you'll love it. If you're not good at use of, you might not love it. But you really need to get good at use of because it's an essential skill. So yesterday we talked about how use sub is usually used to chain rule anti-differentiate. Thank you. So that's almost always the case, but there's once in a while they use use sub for a slightly different technique, and it's a problem like this. Now this guy is hard to integrate because you can't integrate parts of a multiplication problem separately. I can't integrate the first thing, integrate the second thing separately. You just can't do that. Just like derivatives, you can't integrate or differentiate a product piece by piece. You with me?
Yeah.
All right. Now you can, however, make this doable if you know how to use sub well. So sometimes it's the case that they tell you what u to make. So they're saying let u equal x plus 2. Now if I do that, this then in the root becomes u, and that's great, but I can't leave everything else x-ish and just replace a little stuff with u. It's got to either be all x or all u. You follow? All right, so I need to figure out what am I going to put in for x plus 1, and what do I put in for dx? Well, if u is x plus 2, then what's x? X is u minus 2. So what's x plus 1 then? U minus 2 plus a 1, or u minus 1. So with a little bit of, okay, if u is this, then x plus 1 is that, you get u minus 1 going in for x plus 1, and root u is cool. And then what about the dx? If du is x plus 2, then du is dx. So in place of dx goes a normal O to u. Now our whole goal is to try and take a step forward and get something integrable. Is that integrable? Almost, yeah. With a little work it'll be integrable. What should I do? Yeah, if you distribute now, which you couldn't do before when this was in a sum form, I can't really combine those x's that way. Now I can. I get u to the 3 halves minus u to the 1 half du, and now I can integrate. What's the antiderivative of u to the 3 halves? U to the 5 halves, over 5 halves, or 2/5, I heard. Do you agree you raise the power by 1 and divide by the new power? U to the what? Isn't that the derivative?
Wait, am I breaking math?
You're taking a derivative rather than an antiderivative. Don't you go up by 1?
But
Oh, you mean...
do I break math if I subtract those two?
Oh, yeah, you can't do that. I mean, is 2 squared minus 2 to the first equal 2 to the first? Can you just subtract the exponent? That example, let me try. Aberration. How about this one? Is 3 squared minus 3 to the first equal 3 to the first? It is not. That was really unfortunate. Okay. So 2 to the 5th u to the 5 halves minus 2/3 u to the 3 halves plus c, yeah? And am I done? Circle it? Then you gotta plug in, back in for u 2/5, and in place of u goes back with x plus 2, and in place of the next u is x plus 2 to the 3 halves, and it's plus c, and I'm done. Are we cool? Okay, now, today then, we have to deal with, instead of this indefinite integral, the new stuff of the day is, what happens if you have a definite integral? What's the difference between an indefinite and a definite integral? Yeah, definite integral specifies a region, you're really finding an area. Okay, definite integrals mean you're finding an area, and indefinite integrals just mean you're doing an antiderivative and calling it good. You with me? All right, so we're talking definite integrals. We did antiderivatives yesterday. There's a plus c. We had to sub back. Today there's a definite integral problem, and it goes a little like this. All right. So say you're interested in an x region from 0 to 3. In other words, there was an integral from 0 to 3 that had x in it. You follow? All right. Now, if you did a u sub on such a region, and for whatever reason your u is x plus 2, well, if when you u sub everything gets changed, that includes these. These are x values, and these would have to be changed. So if u is 2 more than any x, then the region from 0 to 3 would change from 2 to 5. All right, now the beauty is then, or the good news is that you won't actually have to sub back, because the new limits will be for you. Now, if you're thinking, what are you talking about? Let's just get into a problem and I'll show you what I mean. So you have the same problem roughly as above, but now it's a definite interval. It's got bounds, you see? All right, so we're still going to let u equal the same thing. We're going to let u equal x plus 2, just like we did above. All right. If u is x plus 2, then x is u minus 2. Therefore, x plus 1 is u minus 1. So at that point, and du is dx. All right, so at that point, we're at this stage, u minus 1 root u du. Cool? Now we can't leave negative 1 and 2. Can't leave those. Those are x values. They must be changed to u values. Right? So if x is negative 1, then what's u? 1. U is x, whatever x is, plus 2. So if x is negative 1, then u is negative 1 plus 2, or 1. The lower limit changes to a u of 1. And likewise, when x is 2, u is 2 plus 2, or 4. Bounds change to something totally different. Now I still integrate, so I'm still going to get the antiderivative of u to the 3 halves minus u to the 1 half. And the antiderivative is still 2/5 u to the 5 halves minus 2/3 u to the 3 halves. Yeah? Do I need a plus c on a definite interval? I do not. I instead say, okay, there's my antiderivative, and this is where I'm going to evaluate. Fundamental theorem says I actually evaluate 2 things and subtract. You with me so far?
Yes.
Now the beauty is, normally after I take the antiderivative, I would sub back. I don't have to do that here, because these values, 1 and 4, they are for u, not x. So I can keep those in, and you don't sub back in a definite interval. Just plug in for u. So I would have 2/5 times 4 to the 5 halves, okay? 2/3 4 to the 3 halves, minus 2/5 1 to the 5 halves, minus 2/3 1 to the 3 halves. You see? Oh, this is nothing. Okay? 2/5, what's 4 to the 5 halves? 32. How'd you get that? Okay, do you do the 5 first or the 1/2 first? The 1/2 first, because then you're gonna make it smaller. So what's 4 to the 1/2? 2 square root, so 2, and then 2 to the 5th is 32. So I'm getting 64 fifths there. And what about 4 to the 3/2? Square root then cube, 8, so 16 thirds in the first set of parentheses, and 2 fifths minus 2 thirds in the second set. It's up to you if you combine and combine, but I find it much easier to combine like terms and then combine. So 64 fifths minus 2 fifths is 62 fifths minus 14 thirds, because it's minus -2, it's plus 2, so -16 plus 2 thirds. Very good? Common denominator? 15. The first one you had to multiply top and bottom by 3. Do that without a calculator, your usual. 186. And 14 times 5?
70.
7. 186 minus 70 is? 116 over 15. All right. So you sub with a definite integral, you have to change the bounds and you don't sub back. Change the bounds and don't sub back. So let's look at the next one. Might not even seem like a U sub problem because it doesn't look like a product of two things. And yet it is, because it's got a function within a function. What's your U? Negative x. There's negative x inside e to the. Negative x is the inside of the composite. Therefore, du is -1 dx. Now, we don't have a -1 dx. We have a dx. So dx is negative du. All right? So at that point, then, if we were substituting, we'd have a 4e to the u and a negative du. And I'll probably move the negative and the 4 out front in a minute. Are you with me so far? Okay, now we need to change the bounds. When x is 2, u is -2, because u is the opposite of whatever x is in this case. When x is 3, u is -3. All right, so that is we're going from greater to lesser, but that's fine, no worries. When I took a 2, I got a -2. It has to stay in the bottom. And when, even though it's going right to left, which we will deal with later, that's an integral we're talking about. It's okay.
Okay. I trust you.
Okay, thank you. I appreciate that. What's the antiderivative of -4e to the u? -4e to the u, right? From -2 to -3. What do I put in first, -3 or -2? Always the upper limit, so -3, -4e to the -3, minus -4e to the -2. I don't know how much this is going to clean up, so should we just leave it like that? All right, we'll leave it like that. That's the spirit. Okay, try 2 on your own. I'll be walking around. This is a little different. Feel free to ask about it. Feel free to work with your math amigos. Let me know if you're not sure. Definitely want to make sure you get the right view first and foremost. Yes. The upper
So are we saying u is out of this, or you get x?
Oh, yeah, that makes sense.
get du equals 1 over x dx or x d.
du equals 1 over x dx.
Yeah, so
Which is what it is.
so dx equals x du.
Are we allowed to back up?
So then, but then x.
No, that's what we're showing.
Because you're finding dx.
Yeah, one first one. Oh, hold on. I'm still trying to figure out the value now. Like these are just x's, right? So then you get the tangent u. Sine u. Just plug in one for x and one sine.
So making sure you're on the right track on the first one, what's u? All right, you are choosing well. What's du? Over x dx, that's awesome. So the integral starts becoming more like u cubed du, yeah? All right, cool. Did you already change the limits, or?
Yeah.
Okay, so when x is 1, u is log of 1, which is 0. And when x is e, u is log of e, which is 1. So if you change your integral to that, you're on the right track. Keep going. It's really easy from there. That's not your answer for so far. Stop and fix.
This is a humming.
Yes. So you take these values and subset to your u.
You're struggling to find x. So then x equals
I hope you got 1/4 for the first one. So the question I had in both classes is, can that 2 be taken all the way out? Can that 2 be taken in front? They cannot. It's part of the secant argument. You cannot factor it up front. It's inside the secant. You cannot take the 2 up front. It's not a normal 2. It's a secant equally 2. Okay. Making sure you're on the right track. What's u?
2x minus pi over 6.
2x minus pi over 6. What's du?
2.
2 dx. Do you have a 2 dx? No, you have a dx. So you need to move that 2 to call it 1/2 du, yeah?
Yes.
Cool. When x is 0, what's u?
Negative pi over 6.
Negative pi over 6. When you put in x of pi over 6 in for x, what is u? Pi over 6. Excellent. So did you get a new integral of negative pi over 6 to pi over 6 secant squared u times 1/2? Can I put the 1/2 out front?
Yeah.
You can. U. Cool. Do you recognize that derivative?
Yes.
What is that? That's the derivative of?
Tangent.
Tangent. Last but not least, can you do the trig without fail? What's the tangent of pi over 6? Ooh. What's the tangent of? Root 3 over 3, and what's tangent of negative pi over 6? Negative root 3 over 3. So that's 2 root 3 over 3. What's 1/2 of 2 root 3 over 3?
2 root 3 over 6.
Root 3 over 3. Right? Or if you like, you can keep them. All right, last but not least, common multiple choice problem. Try that one and see what you think. A, B, C, D, or that's all. No E. Never mind. A, B, C, or D. All right, so we conclude.
D.
D, do we agree? It is D.
I agree.
Okay, do we all get that? All right, make sure you found these distractors are very common. Did you change the limits accordingly? Did you get the right DU? This is for a person, this is to distract a person that doesn't know how to find DU work. This is somebody that doesn't know how to change the limits for you. This is somebody that also doesn't know how to fix the DU. Okay, it is D. So if you did not get that, let me know and we can go over it. I'll come to your desk if you're embarrassed. All right, questions on set 50.
Yes.
Okay, 50, 21,
16.
16, 1, 21, 16, 1. That replacement is probably something you want to talk about.
Did I do it right? Oh, never mind. I did it right.
Which one?
21.
Somebody else has to play this one. Okay. Okie dokie. Are you ready? Okay. 21 is this guy. Oops. 1 over n. Ah, shoot, I keep. 1 over n, 2 over n, 3 over n, through n over n, yeah? All right, and I said I want you to write this as a Riemann sum, and then also talk about an integral. So, is a Riemann sum, isn't this, the limit can stay, but the 1 over n is fine. Isn't the sum this guy here, yeah? All right. So in terms of what's always there and what's counting, that's really what you should focus on. What's always there, you can say is always there. It's over n, it's there for all of it. Now you say, all right, what's counting? Because that's your I. You agree the numerators are counting. 1, 2, 3, and so the top is I. The counter is there. All right. So far, so good. Okay. Now, once it's some summation notation, it's still not home free. This is a hard problem, but this is typically the delta x, yeah? And so it must be the case that it's 1 unit wide. All right. Now, does that mean that I can assume it's going from 0 to 1, or is it still possible it's going from 1 to 2, or 2 to 3? Could still be a lot of things. Yeah, I just know it's 1 wide so far, right? But if it starts at 1 or 2, if it started at 1, wouldn't it be 1 plus a delta x, and then 1 plus and 2 delta x's, and so on? And do you see anything like that? 1 plus starting point plus delta, or is it just delta? Just delta. That means it must start at 0. So I feel confident saying it's 0 to 1 for my integral. All right, cool. Next thing is, all right, so we know that the typical is here is delta x, and this is f at different points, yeah? It seems like the function is just right there. So my question for you is, there's two very common answers. Is the function 1 over x, or just x? It's just x. Remember, you're putting in 1 over n, 2 over n. So when you put in 1 over n, what came out is a 1 over n. And when you put in 2 over n, what came out is a 2 over n. So it seems like the function is just y equals x. Whatever you put in is what you get out. Hold on this. So are you, that's confusing, but are you with me? Okay, I know this is not easy. We'll practice this more. But it's 1/2 x squared from 0 to 1, so your answer is 1/2. Okay. Don't think that the over n thing means the function is a fraction, because the over n thing is always there. Yes? Whatever, and do it like in a summation way? You could. The problem is, what if the function wasn't something you had a formula? So if I understand you right, you said something like this is 1 over n squared times I, yeah? Is that what you said? If you did it that way, it'd be 1 over n squared times n plus 1 over 2, and take the limit. Yeah, that's fine. Problem, and that works great here, so feel free to go for it. But if the problem was ugly, you didn't have a formula, then you'd be something. How about this guy? I'm not sure if I didn't do an example like this in your notes, so you should make good corrections to this, because this is not big on the AP test, but it's really big in college calc classes. They do a lot of curve sketching tips, a lot. Many professors don't like graphing calculators. They're still old school in terms of Calc 1. So let's go through this. Back in the day, before graphing calculators, this is how you graph something really ugly. You would use the first derivative to find where it's increasing or decreasing. You use the second derivative to find where it's concave up or concave down. And between all of that, you get a really nice picture of the graph. That's the problem here. So let's go with f prime. First of all, I can't find increasing until I know f prime positive. So f prime is 3x squared minus 6x minus 9. Write fairly small, please. That's 3x squared minus 2x minus 3. That factors into x minus 3, x plus 1. So I get critical numbers at -1 and 3. Okay, now hold off on making a sign chart there. We're going to make a super sign chart of both first and second derivative action, kind of like over here. We're going to make a big old sign chart of lots of information. Okay, so f double. F double is 6x minus 6. That changes sign, or something interesting happens there at 1, yay? Now, if I were to make intervals of all the interesting points, then the intervals would be -1, 1, and 3,
Good
yeah?
morning, Dublin Jaguars. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, so I'd have one integral,
Do you have Jaguar spirit?
another integral,
Sidelines and getting to games for
or
free. You
interval,
want to help get the crowd going and our mascot,
4
TJ?
intervals, yeah?
If you're interested in the Asian Cognito visit, talk to Mr. Pelican. The University of Arizona will be in counseling during this hour. Tucson quote 360
Okay.
days of sunshine per year.
So the
is a
first
ski
derivative.
paradise. They have the southernmost ski area in the United States. Check them out today by signing up in the
The
college.
first
Visit Club.
derivative
Next week, college
at
visit
maybe
includes
-2
Colorado,
is
CSU,
positive.
Pine, Metro, and BU.
At 0, negative.
We have gluten-free. All products go to help
1 to 3, still negative.
Don't forget, you can
And
nominate
after
teachers
3,
for the Teacher of the Month award.
positive.
Go to the Devlin homepage and click on the Teacher of the Month
You see?
icon found next to the Devlin press release.
Negative 1, it would be negative before negative 1, or before 1, and positive after.
No school, the girls would love to see you on your day off.
But now the question's easy.
In the mood for
Where is it concave up and increasing?
Come to Noodles and Company on 247 in Kipling tonight from 4 to 8 to support your band and winter guard.
Good.
Be sure to mention you're there for them. Anyone interested in participating in the UNC math competition, please talk to your math teacher. The contest will take place during first and second periods on Tuesday, October 29th. Again, please see your math teacher for info and absence.
Okay,
Go
16.
school on Friday, come out and support your Devlin gymnasts at the Varsity Jetco League Championship. Competition starts at 4:30 p.m. at Pomona High School. Senior high students interested in auditioning for Matilda the Musical should come to the information meeting during 7th hour today in the auditorium to learn about the show and pick up audition materials. Students interested in playing for kids for the musical should also attend this meeting. Attention Jack, would you like to have your friend's hilarious childhood photos of the yearbook? Send us your funny or cute childhood pics, more recent or
first derivative is positive 2
the
sin
opportunity
x,
to
right?
recreate them and relive your childhood days.
So the second derivative is
Yearbook.jack@gmail.com or DM them to your
2
yearbook.
cosine of x.
Junior high students, all entries will need to report their ICAP
2 cosine 2.
7 hours. Today is the first quarter of class news session.
Is that not what the answer was?
Hey Jack, time for your daily day today. Happy National Food Day. If you want to celebrate, come to Noodles and Company from 4 to 8 on Super 17. Have a great day, Dad.
The book says negative. I prefer just saying 2 cosine 2, not even using something. I don't know why they used it like they were. What is a one-stop question? Anyone? Yes?
Well, no, I was just wondering, is 51 going to be due to?
No, just 50. Okay. Does anybody need one? All right. All right, 50 is due, not 51. All right, so have a super duper weekend, people. You left in 4-day week. First 3 days, nothing to stay heavy. Have a good weekend. Yes.
Since I get sent 50 to you by Monday, is that a good
Sure.
deal?
Yeah. Thank you.
Hi. So how
can you decipher, or, how can you decide if there's, like, for example, a car's driving, like that truck problem, and he had to be going 70 miles per hour at one point to get 70 miles down the road?